Good afternoon and welcome to Carlam Cymru for session number 4 of mathematics. This afternoon the session will be run by Mrs Alexa Jones from Gowden Comprehensive School. The session will last 45 minutes where the teacher will go through the relevant subject content. If you have any questions, please use the question and answer section and we will endeavour to answer your questions during the session. The session will be recorded with the recording and any resources uploaded to the e-sgol website in the Carlam Cymru area. Over to you, Mrs Jones.
Thank you, Mr Walters. So today's lesson, we're going to have a look at probability, and it would be a good idea if you had a calculator for at least some of the questions today. So to start us off, here we are. I'd like you to have a quick look at these questions. And it says evaluate, and that just means work out the answer to. So can you evaluate 0.2 multiplied by 3 and 0.2 multiplied by 0.3? Sorry, 0.2 multiplied by 3 and 0.2 multiplied by 0.3. And I'm just going to give you about 20 seconds to try those, and then we'll have a look at the answers. Okay, so let's have a look at those. And don't forget that any time today that you need more time, just pause the presentation and then you'll be able to continue it at your own pace. So for the first one here, let me just get my pen back because it's disappeared. There we go. For the first one, I'm going to do 0.2 multiplied by 3. Now 0.2 multiplied by 3, that's the same as adding up 3 lots of 0.2. And if I added up 3 lots of 0.2, I would get 0.6. So 0.2 multiplied by 3 is 0.6. Now 0.2 multiplied by 0.3, the answer to that can't be 0.6 because 3 lots of 0.2 is 0.6. So we're going to have a look at what the answer to this one could be. So if we look at this, what we've actually done is we've divided 3 by 10 to get to 0.3. So we're going to need to divide the answer by 10 as well. So the answer to 0.2 multiplied by 0.3 is 0.06. And that's a really common mistake that people make when they're multiplying decimals. They forget that 0.2 multiplied by 0.3 is 0.06 and they just write 0.6 down. So the other thing that it's worth us having a look at before we start probability is adding and multiplying fractions. So again, it says evaluate, so just work out the answer to. The first problem is 1/2 add 1/3. And the second problem is 1/4 multiplied by 2/3. So again, I'm just going to give you 20 seconds to have a think about those and then we'll have a look at the answers. Okay, so again, if you need more time, don't forget you can just pause the presentation. So for the first one, 1/2 add 1/3. Now, a common mistake for this would be for people to say that the answer to this would be 2/5, just by adding the tops and adding the bottoms, but that isn't the case. So what we actually need to do is we need to make the fractions have the same denominator. They need the same bottom number before we can add them up. So I'm going to take 1/2 and I'm going to take 1/3 and I'm going to change both of them into an equivalent fraction that has the same denominator, the same bottom number. And 2 and 3 both go into 6. So I'm going to change these both into something over 6. Now to get from 2 to 6, I multiply by 3, and if I've multiplied the bottom of my fraction by 3, I have to do the same to the top to make an equivalent fraction. So 1/2 is the same as 3/6. And then I do the same to 1/3. So I say to get from 1/3 to get from 3 to 6. I multiplied the bottom part by 2. So I have to do the same to the top, and 1/3 is the same as 2/6. Once I've done that, I can change this problem and then I can do the addition. So 1/2 is actually 3/6 and 1/3 is 2/6. And now these have the same bottom number, the same denominator. I can just add the tops. So 3 add 2 is 5. And then the bottom stays as 6. So a common problem here would be for someone to say that this was 5/12, but it is only the top that you add. So the rule with fractions is they must have the same bottom number, the same denominator, and then you just add the numerators, the top. Now, when it comes to multiplying fractions, it's a different rule. And the rule when you multiply fractions is you just multiply the top and you multiply the bottom. So multiply the numerators and multiply the denominators. So for this one, 1 multiplied by 2 is 2. And then 4 multiplied by 3 is 12. So this is 2/12 as an answer for this one. Now, let's have a look at some probability questions. So this is the first one, and it says a fair 6-sided dice is rolled. What is the probability that a 4 is shown on the dice? Circle your answer. And we have a range of answers here. It's a multiple choice question, and we just need to circle the one that's correct. Well, if we think about a dice, on a dice, it's got 6 faces, and the numbers on it, we've got 1, a 2, a 3, a 4, a 5, and a 6. And it says, what is the probability that a 4 is shown on the dice? Well, there's only one 4. So there's 1 4, and there are 6 numbers altogether. So the chance, it's 1 out of 6. But we don't write probability like this. So the way that we would write probability is it either needs to be written as a fraction, as a decimal, or as a percentage. And fractions are quite common. So 1 out of 6, I can write that 1/6, 1/6 as a fraction. So the correct answer for this one is here on the end, it's 1/6. Let's have a look at the next question. So this one says 50 raffle tickets were sold at a charity event. Sian has a 20% chance of winning the top prize. How many tickets did Sian buy? Circle your answer. Okay, so if Sian's got a 20% chance of winning the top prize, that means that she must have 20% of the tickets. And we're told in the problem how many tickets there were. There are 50. So what I'm going to need to work out for this one is I'm going to need to work out 20%. Just rub that out. I am going to need to work out 20%. Change my pen. 20% of 50. Now, in the exam, 20% of 50 written like this, that's not accepted as workings. You wouldn't get a workings mark for it. So what you need to do is you need to change this of into multiply, because if you change that into 20% multiplied by 50, that then becomes a method. So you would get a mark for that, even if you then couldn't work out how to solve the problem in most questions. So for 20% of 50, well, if this was a non-calculator paper, I would start by saying, let's find 10%. So I would do 50 divided by 10, divide by 10 to find 10%, which is 5. And then 20% would be twice as much. So I'd do 5 multiplied by 2, and the answer would be 10. If this was a calculator paper, I would just do 50 multiplied by 0.2 or 50 multiplied by 0.20, and that would take me straight to an answer of 10. So here, 10 is the answer for the number of raffle tickets that Sian had bought. Okay, so this question says, a box contains 4 coloured cards. 1 card is blue, 1 card is red, 1 is green, and 1 is white. A card is drawn from the box at random. Which letter A, B, C, D or E represents the probability that the card drawn is not blue. Okay, so we need not blue. And the other relevant fact here is that there are 4 cards in this box. So we've got 4 cards, 1 blue, 1 red, 1 green, 1 white, and we want the probability the card is not blue. And you can see we've got a probability scale here. And it ranges from 0 to 1. And 0 in probability is something can definitely not happen. So it's impossible. And then 1 in probability means that something is certain. It's definitely going to happen. So looking at this, I can put fractions or I can put percentages on here. So see here, this is halfway along the line. So this would be a half, and then B halfway between 0 and a half, that would be a quarter, and my D value here would be 3/4. So it's quite handy to fill those in so that I can think about what I'm going to do here. So it wants the probability that the card drawn is not blue. We've got 4 cards and 3 of them are not blue. So it's 3 out of 4, which we can write as 3/4. So 3/4 of them are not blue. Circle the correct letter on the probability scale. Well, I can see that it must be D here for the letter that represents the probability of that card not being blue. So this is quite a common question. Where you've got something like this and you've got to fill in the rest of the table. It says a box contains 500 discs, identical in shape and size. A picture of one of 4 Welsh castles is printed on each disc. A disc is chosen at random from the box. Complete the table below to show the probability of choosing a disc showing Dynevor Castle. So we've got 4 castles here. And 3 of the probabilities are filled in, and this last one isn't. Now, what we need to know here is that total probability adds to 1. So total probability, it adds to 1. So I'll just write that down. So what we need to do is we need to add up what we've been given and then work out what is missing to make this add up to 1. So I'm going to add up 0.36, add 0.12, add 0.24. And when I add those together, I am going to get, let's have a look, we've got 0.72. So to work out how much is missing here, I do 1 subtract 0.72, and that is 0.28. So the probability of it being Dynevor Castle is 0.28 because all of these have got to add up to 1. For the next part of this question, it says how many of the discs showed a picture of Harlech Castle? Well, I know the probability of it being Harlech Castle is 0.12 from the table here. And then I need to look further back into the question. And up here, it says there were 500 discs. So in order to find out how many of them showed a picture of Harlech Castle, I do 500 multiplied by 0.12, and 500 multiplied by 0.12 is going to give me 60 discs. So there were 60 discs with a picture of Harlech Castle on them. Okay, so I've got one like that for you to try now. So this one says 200 young people are taking part in a conference held at Aberystwyth. One of the young people is chosen at random to be the chairperson. Complete the table below to find the probability that the person chosen lives outside the UK. And you've got your probabilities here in your table for North Wales, Mid Wales, South Wales, elsewhere in the UK. And then we've got this box to fill in for outside the UK. And then for the next part, it wants to know how many of the young people live in Mid Wales. So I'm going to give you about 30 seconds to have a look at this before I go through it. See if you can try this one for me. Okay, let's have a look at this one then. So we needed to add up the probabilities that we've been given. So the probabilities we've been given, 0.2 plus 0.3 plus 0.25 plus 0.15, those add up to 0.9. And then we do 1 subtract 0.9, and that leaves us with 0.1. So the probability that the person chosen lives outside the UK is 0.1. Now, for the second part of this, how many of the young people live in Mid Wales? Well, up here it says there were 200 young people. So it's going to be 200 multiplied by 0.1, and that gives us 20 young people. Oh, I've answered the wrong question. I'm looking at outside the UK. Right, let's change that. I had misread it. Let's have a look. It says, here we go. How many of the young people live in Mid Wales? This is the one I should have been looking at. So it's 200 multiplied by 0.3. So the answer to that one is going to be 60. There we go. Okay, so let's have a look at the next one. It says a game uses 15 coloured cards. There are 5 red cards, numbered 1 to 5, 5 yellow cards, numbered 1 to 5, 5 pink cards, numbered 1 to 5. The cards are all placed in a box. One card is chosen at random from the box. Complete the grid below to show all possible outcomes. So we've got colours here. So we've got pink already. Let's put the other ones in. We're going to have red and we're going to have yellow as being options. And then the numbers were 1 to 5. So it's 1, 2, 3, 4 and 5. And now we're going to fill in this grid. So it shows us up here just to use the first letter. So we'd have a red 1, a red 2, red 3, red 4 and red 5, yellow 1, yellow 2, yellow 3, yellow 4, yellow 5, and then we'd have pink 1, pink 2, pink 3, pink 4 and pink 5. The next thing that it says, oh, right, something wrong with my video, but we'll keep going. The next thing it says is, what is the probability that the card chosen is a pink card showing a number greater than 3? So a pink card showing a number greater than 3, I have this one here, and I have this one here. So the probability, I have got 2 pink cards with a number greater than 3 out of, and then altogether, if we count the number of boxes we've got here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the probability that the card chosen is a pink card with a number greater than 3 is 2 out of 15 altogether. I'm just going to see if I can put that video back on. Just having a little bit of difficulty there. Okay. So this next question, it says, Lloyd and Megan have made 2 spinners for their stall in the school fair. They need to work out some probabilities to help decide how to give out the prizes. Diagrams of their spinners are shown below. Each person who takes a turn at the stall must spin both spinners. The 2 scores are added together to give the total score. Find the probability that the total score for any person is 20. Okay, so with this, I can do this the same way as the last question, and I've started a grid here, and I could say, and we're doing the total score, we're adding together, so we're going to add these spinners. There we go, that's better. So we're adding the spinners, and we've got this one spinner with a 2, a 4, a 6 and an 8. So we've got 2, 4, 6 and 8. And then we've got the other spinner that's got 2, 4, 6, 8, 10 and 12. So we're looking for the 2 scores added together to give the total score. So I could just fill this in. And if I fill this in with all the possibilities, adding the numbers, I got 4, 6, 8, 10, 12, 14, and then I would get 6, 8, 10, 12, 14, 16. I would get 8, 10, 12, 14, 16, 18. Sorry, having problems with my pen. And then here I've got 10, 12, 14, 16, 18 and 20. And then looking at these, you can see there's only one way to get 20. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got 24 different possibilities. So the answer to this question is 1 out of 24. And this is one way that I could have answered this question. But it's not the only way that I could have answered this question. So what I could have done with this question is I could have looked at it and said, well, in order to get 20, the only way you can get 20 is by scoring an 8 on this spinner and by scoring a 12 on this spinner. And the chance of getting an 8 on this spinner is 1 out of 4, 1/4. And the chance of getting a 12 on this spinner is 1 out of 6, 1/6. Now, for both things to happen, you can multiply the probabilities. So for both of these things to happen at the same time, I could do 1/4 multiplied by 1/6, and then multiply the tops, that's 1, multiply the bottoms, 1/24. So this is another way of doing it. There's more than one way often of doing these questions. Let's have a look at another question. So this one says, Logan has 2 fair dice. Dice A is a cube, it shows the numbers 1 to 6. Dice B is a tetrahedron, it shows the numbers 1 to 4. And a tetrahedron has got 4 faces, so it's just got each of those numbers on one time. Logan throws both dice. What is the probability that he throws a 5 on dice A and a 3 on dice B? So this is a lot like the question that we just looked at, whereby I could start drawing a sample space diagram and trying to work it out, but I could just work out the probability of each of these things, and then for both things to happen, I can multiply them together. So the chance of throwing a 5 on dice A, well, there's 1 5 out of 6 numbers. And then the chance of throwing a 3 on dice B, well, there's 1 3 out of 4 numbers. So with this one, I've got 1/6 multiplied by 1/4. So once again, this is 1, multiply the tops, multiply the bottoms, 1/24 is the answer to this question. So you can do these fairly quickly. Let's have a look at the next question. Now, this one says, Asif has a biased 4-sided dice. The dice shows the numbers 10, 20, 30 and 40. Asif throws the dice once. The table below shows the probability of obtaining each number. So the chance of getting a 10 is a half, a 20 is a fifth, 30 is a fifth, and 40 is 1/10. What is the probability Asif throws a 30 or a 40? Now this is slightly different because with this, it's what is the probability he throws a 30 or a 40? Well, the chance of him throwing a 30 is 1/5 and the chance of him throwing a 40 is 1/10. And the chance of him throwing a 30 or a 40, you just add those probabilities together. So I'm going to do 1/5 add 1/10. And then, of course, you can either do this on your calculator if it's on a calculator question. And if it isn't, we would need to change 1/5 into 2/10 using equivalent fractions before we add them. So the problem would become 2/10 add 1/10. So the probability here would be 3/10 altogether. Now we're going to have a little look at tree diagrams. So this is the first tree diagram, and it says, visitors to Snowdon can either walk or take a train to the top of the mountain. On a particular day, a visitor is chosen at random. The probability this person is female is 0.42. The probability this person took the train is 0.35. The decision to walk or take the train is independent of gender. This means the two things have no connection, then it doesn't affect the second thing at all. So complete the tree diagram shown below, and we've already been given a number here. I know it's very small, but we've been given the 0.42 here for female. Now, total probability adds up to 1, and the branches here are going to add up to 1. So I need to say to myself, what do I add to 0.42 in order to get to what's going to be on the male branches here? So you do 1 subtract 0.42, and the answer to that is 0.58. So it's going to be 0.58 here on this branch, and the pair of branches, they add to 1. So I dealt with this first part here, and then it says the probability this person took the train is 0.35. So I'm going to fill that in on my diagram. So for train, it's 0.35, and down here again for train, it's 0.35. I'm now in the same situation where each pair of branches adds to 1. So I say to myself, what do I add to 0.35 in order to get to 1? So what I'm going to do with that one is I'm going to do 1 subtract 0.35. And when I do that, I get 0.65. So that means the chance of walking is 0.65. And again here, 0.65. And notice that the branches at the top here, they add to 1. And then we've got the same branches with the same numbers on repeated down below. Now, the way that these tree diagrams work is we follow along the branches. So here, the chance of being female and walking, you follow up the branches. Female and walking is here, female and walking, and you multiply up the branches. So that would be 0.42 multiplied by 0.65. The chance of being female and taking the train, so I'm just shortening this for female and train, would be 0.42 and then followed on this branch 0.35. So that would be 0.42 multiplied by 0.35. The chance of being male and walking is 0.58 multiplied by 0.65. And male and catching the train is 0.58 multiplied by 0.35. And you don't have to work all those probabilities out. That's just showing you where they've come from. But really, you only have to do the ones that it asks you for in the question. So the question down here carries on, and it says the person chosen at random wins a gift voucher. What is the probability that this person is female and travelled up the mountain by train? So I want this one here. So female and travelled up the mountain by train. So you just multiply those two probabilities together. So we're doing 0.42 multiplied by 0.35. And when I pop that into my calculator, I get 0.147. Okay, so I've now got one of those for you to have a go at. So very, very similar. It says, Rowena sometimes wears a hat and sometimes wears gloves. The probability she wears a hat on a given day is 0.6. The probability that she does not wear gloves on a given day is 0.2. Complete the following tree diagram. And then at the bottom it says, calculate the probability that on a given day, Rowena wears a hat but does not wear gloves. So I'm going to give you 30 seconds to try that now. And if you need a bit longer, you can always pause the video. Okay, let's have a look at this one then. So we've got the probability that Rowena wears a hat as being 0.6. So not wearing a hat, these branches must add to 1, so that must be 0.4. The probability that Rowena does not wear gloves is 0.2. So to make these branches add to 1, I've got to have 0.8 for Rowena wears gloves. And then the branches underneath here are the same as the branches above, 0.8 and 0.2. Calculate the probability that on a given day, Rowena wears a hat but does not wear gloves. So we're going, wears a hat, does not wear gloves. So we want a hat with no gloves. So the probability following along those branches is 0.6 multiplied by 0.2. And 0.6 multiplied by 0.2 is 0.12 as the probability that she wears a hat but does not wear gloves. Okay, let's have a look at another question. So this is another tree diagram and it says Leah is visiting Cardiff. The probability that she will go on a bus tour is 0.3. The probability of Leah seeing a show at the Millennium Centre is independent of her going on a bus tour or a tour bus. The probability that she goes on a tour bus and sees a show at the Millennium Centre is 0.24. Complete the tree diagram. And then at the bottom, we've got a question. Okay, let's start with completing the tree diagram. So we've already been given 0.3 for going on a tour bus. So does not go on a tour bus must be 0.7 because those branches add to 1. And then the next thing we've been given is we've been told the probability she goes on a tour bus and sees a show at the Millennium Centre is 0.24. Now, the main problem that happens here is that people will go and write this 0.24 here where it says sees a show at the Millennium Centre, but that's not what they've given us. So what they've actually told us here is the chance that she goes on a tour bus and sees a show at the Millennium Centre is 0.24. So this is tour bus and sees a show. So goes on the tour bus and sees a show. That's what's equal to 0.24. It's not her seeing a show at the Millennium Centre that's 0.24, it's this part at the end. So what we're going to need to work out is we've got to work out is what did we multiply 0.3 by to get to 0.24. So I'm asking myself 0.3 multiplied by something gives me 0.24. And I know that 3/8 are 24, so this probability here must be 0.8. But if I didn't know, and this was a calculator question, I would just do 0.24 divided by 0.3, and that's where the 0.8 would come from. So the probability of her seeing a show at the Millennium Centre is 0.8, which means that the probability that she does not see a show at the Millennium Centre is 0.2 because these branches must add up to 1. And then the branches underneath are the same as the ones above. So this one must be 0.8 and this one here must be 0.2. Calculate the probability that Leah does not go on a tour bus and does not see a show at the Millennium Centre. So we're going down here, does not go on a tour bus, and here does not see a show at the Millennium Centre. So we want this one, no tour bus and no show. So that's going to be 0.7 multiplied by 0.2. And that is 0.14 is the answer. So you have to be super careful when you are given one of these, whether you've been given the probability that goes here, the probability that she sees a show at the Millennium Centre, or you might have been given the probability that goes here, does not see a show at the Millennium Centre, or they might have given you the probability of two things happening, which means you've got to work these out by working backwards. So I've got one like this for you now. So here it says, Dylan is having a weekend break in Wrexham. The probability that he will visit Erddig Gardens is 0.7. The probability of Dylan going to the Bersham Heritage Centre is independent of him visiting Erddig Gardens. The probability that he visits Erddig Gardens and goes to the Bersham Heritage Centre is 0.28. Complete the following tree diagram. And on this diagram, I know it's very hard to see, but there is actually a 0.7 put on here for you already. So you need to fill in the rest of the tree diagram. And then the second part of this is for you to calculate the probability that Dylan visits Hydref Gardens but does not go to the Heritage Centre. So I'm just going to give you 30 seconds, and then if you need more time, you'll be able to pause the video. Okay, so I'm going to go over the answer to this one now. So if the probability that he visits the gardens is 0.7, then the probability that he doesn't visit the gardens must be 0.3 because these branches need to add to 1. Then we're told that the probability that he visits the gardens and goes to the Heritage Centre is 0.28. So that's here. So visits the gardens and goes to the Heritage Centre, that's going to be here. And then we've got to work out what this number is here. So I'm saying 0.7 multiplied by something gives me 0.28. And I know that 7 4s are 28, so this must be 0.4. So I must have 0.4 here. And that means I must have 0.6 here because the branches, each pair adds to 1. So this is 0.4 and this is 0.6. Then it says, calculate the probability that Dylan visits Hydref Gardens but does not go to the Heritage Centre. So this time I'm going up here as he visits the gardens and then down here because he does not go to the Heritage Centre. So I am doing 0.7 multiplied by 0.6, and that is 7 6s are 42, so it's 0.42. That number is going to be less than 1 because total probability adds up to 1, so that number couldn't be larger than 1. Let's have a look at the next question we have here then. So it says, a bag contains a number of different coloured balls. A ball is selected at random from the bag. The probability of selecting a blue ball is 0.3. And then part A, why is the following statement incorrect? Explain your answer clearly. And the statement is, more than half the balls in the bag are blue. So let's look at this. We've been told that the probability of selecting a blue ball is 0.3. And down here, it's talking about more than half of the balls. Now, you might just look at it and go, well, 0.3 is less than a half. And that's true. And that is the reason that the statement is incorrect. But when we're asked to compare things, and in this case, we're asked to compare fractions with decimals, we need to change them all into the same thing. So normally, either decimals or percentages are the easiest. So 0.3, that's the same as 3/10, and that is the same as 30%. Whereas a half is 0.5 or it is 50%. So you just need to make sure that you've got them all as either decimals or as percentages, or you'd have to use equivalent fractions. So fractions with the same number on the bottom. So here I'm going to choose percentages because I think they're a little bit easier. And I would say 30% is less than 50%. So less than half the balls. So less than half the balls are blue. And often with an explain question like this, the examiner is looking for you to write a sentence. So we are looking for a sentence in response to this. B, what is the probability that a ball selected at random from the bag is not blue? Well, the chance of it being blue is 0.3 and total probability adds up to 1. So I just do 1 subtract 0.3, leaves me with 0.7. So 0.7 is the chance that that ball is not blue. Then I've got there are 50 balls in the bag. How many of them are blue? Well, 0.3 of them are blue. So it's 50 and multiplied by 0.3. And 50 multiplied by 0.3 is 15. So there would be 15 blue balls in that bag. Okay, I think we've got time to do another question. Let's have a look. Now, this one, it's quite involved, this one, so we're going to have to read it carefully. It says, a box contains 400 beads of the same size and shape. 35% of the beads are green. 2/5 of the remaining, and that's an important word, 2/5 of the remaining beads are blue. The only other colour of bead is white, so we've only got green, blue and white. One bead is picked at random from the box. Find the probability that a white bead is picked. Well, I'm going to need to work out how many of each different colour bead I've got in this box. So looking at this, the first thing that it says is that 35% of the beads are green. So there are 400 beads and 35% of them are green. So I need to find 35% of 400. And to do that, I'm going to do 400 multiplied by 0.35. If this was a non-calculator paper, I would probably find 10% and I would find 5% and I'd add up 10% and 10%, 10% and 5% to get to 35%. So that gives me 140 green beads. So I found the number of green. Then it says 2/5 of the remaining beads are blue. So I've got to work out how many beads are left. Now we started with 400 beads and I know I've got 140 green beads. So subtracting 140 from 400, I'm left with 260 remaining beads. And I've got to find 2/5 of these. So a couple of ways of doing that. On a calculator paper, I would put 2/5 multiplied by 260 into my calculator. On a non-calculator paper, I would divide 260 by 5 to find 1/5, and then I would multiply it by 2 to find 2/5. And that comes to 104. So I've worked out 104 of these beads are blue. Then it says the only other colour of bead is white. So now I'm in a position to find out how many white beads I've got. So I started with 400. I've got 140 green and I've got 104 blue. So if I subtract both of those from 400, I will have 156 white beads left. Okay, so now I've worked out how many beads of each colour I've got. It says one bead is picked at random from the box. Find the probability that a white bead is picked. Well, I've got 156 white beads, and that is out of the 400 beads in the box. So my answer to the probability of a white bead being picked is 156 out of 400. Okay, so let's have a little look at the things that we've looked at today. Okay, so the main things that you need to remember from today, firstly, that total probability adds to 1. So if the chance of something happening is 0.2, the chance of it not happening will be 0.8 because total probability adds to 1. You can give your probability in decimals, in fractions, or in percentages. You need to remember that if you are giving something sort of as a percentage or as a decimal, the probability is going to be the most it can be is 1 because the total probability would add up to 1. If the question says, what is the probability of this and this happening, you multiply the probabilities, you multiply the decimals or you multiply the fractions. Whereas if the question says, what is the probability of this or this happening, you would add those probabilities together. And when you've got tree diagrams, you need to read the question really carefully and you need to work out what have they given you, what exactly is it? Have they actually given you something that goes on the branch, or have they given you a probability at the end and you've got to work backwards to find out what should go on the branch? And finally, if you are dealing with something complicated, if you're dealing with two events, you could always draw a diagram to help you. Okay, well, thank you very much for joining us. All of the documentation will be uploaded to the website, and thank you again for joining us.